Okay, so just had to stop and look at the code here versus my previously made code here and figure out what's going on here. Which is basically it's a good thing. You may have to do this as well going through this, because I obviously made a mistake, and you as a watcher trying to code this might do some mistakes as well. So that's why this data set is great. You can see the outputs of the stuff you made. Had to print this and print the true values, print the loss D inputs, the sigmoid D inputs. So I use that to figure out, compared to my other thing of code, figure out which numbers are off, because I use the same random seed, so the numbers should be exactly the same. Okay, so I found two things here. The y value, if you were to do yij as it previously was, that will make y flow, or basically b at values, equal to this guy's shape here, which it's not. It should be just one row. So add in this -2, we'll fix that part. Also, here at the y, for our previous example, we had it as num samples by num neurons. It should not be that. It should be num samples by num outputs, just one output. So that will make that better. The other thing, that should be all that you should need. I tested out, there was a slight difference between the two here, but I'm going to go back to this the way we originally had it. Save that. That should not have made a difference. So let me try that again here. Okay, so I guess it did make a difference. Okay, so that's the code we previously had. I will comment it out versus this code. Delete that. Which, it's exactly the same. There's just, as far as I could see, it's exactly the same. There's just different parentheses around these, which must just mess with the order of operations and somehow under the hood made it different. If anybody sees what the difference between this here versus this, all that, let me know in the comments if you see an actual difference, if I just mess this up somehow. But yeah, let me know. But basically you would just change this whole row, replace it with this one. There is slightly different parentheses. So look very carefully. Pause it, take time to look carefully. And that should make the other difference. Double check that. Okay, so the numbers match. And now if we go here and get rid of these print statements, let's see. The only one should be in this if statement. I had switched it down to be able to do all those other print statements, but we'll go up to 300. Check every, let's say 60. We'll make it 301 so you see all that. And now it should learn. So output versus true Y value. I did make that slight adjustment. Printing the true Y values. We'll go down here to the bottom. So it is learning. That those are going up. That will go down with time. Should go down with time. 60, it does go down like here. Comes back up. Let's do more iterations. Let's do like 1,000. I'll do 100. Go down to the bottom here. So that now that all these have learned, there's like nothing, there's very little pushing things up here. So the derivatives of this one is mattering more now. It just learns latest. So 0.4 down to 0.3. If you go to like probably 2,000, it'll drop a bunch more. So that this will get close to 0 and these will stay close to 1, which is exactly like our data set. And that is how you make this one. The next one will be, I'm going to make this whole thing with MNIST dataset so we can use a categorical cross entropy, predicting different classes. And either before or after that, I'm also going to mix in, yeah, probably after that, I'm going to start mixing in some CUDA code, which will be, there's other people who are doing CUDA code with, just doing CUDA code videos, but as far as I have not seen anybody putting multiple layers together or a layer like matrix multiple with a nonlinear activation. So that's the stuff I'm gonna add in. Yeah. See you in the next one.